Read the problem carefully. What they given now? Same momentum when same braking force is applied, then which one will come to rest at a shorter time, previously shorter distance. Okay, now shorter time. Yeah. In this case, whenever the shorter time case is given, here we use the impulse relations we use. And what is the impulse now here? Impulse formula. Impulse equal to what you tell me now here? So that is equal to F into T. That is equal to what? Tell me now. Change in momentum now delta P. So that means here, look at now here in this case. So now this is a braking force means opposite direction. So that's why we can say minus F into T na. And delta P means what? Tell me now. M into final velocity minus initial velocity. So that is final velocity is how much? 0. That is M into what I can say now here? Minus U na. So this will come to be a what? Tell me now. F into T, which is equal to what? Tell me now here. M into U na. So they are saying same momentum. What is the so they are saying it as a the initial momentums are same. Yes, initially both will have same momentum. Okay. Now Ft, it will come to be what? Tell me now in this case. Now this is F into T, which will be equal to P na. Now, so from this, what I can say now, T value, T is equal to P by F. Now you see what they're saying here. Which terms are same? So those terms we circulate now here. Momentum same. And force is also same only na. So momentum same, force is same. That means what we can say now? T is also same I can say. Yes sir, now both will get cancel each other na. That means which one will come to shorter time? Both will come simultaneously. At a time will come to rest. Okay. Both vehicles. Both will come to rest. Both will come to rest simultaneously.